Hi everyone, welcome to my YouTube channel. Today we will be discussing about state space or the Dirac notation. So what is Dirac notation? Dirac notation is independent of coordinate system. That is like we define position vector in Cartesian coordinate system, polar coordinate system or cylindrical coordinate system. Everywhere we define the position vector as r. When we are saying that the position of a particle is given by r, we are not saying which coordinate we are actually using. Similarly, Dirac notation is that kind of vector space. As this space doesn't have a form, or as we can't imagine or visualize a space like that, this is known as an abstract vector space. This space denoted by a symbol epsilon r. The state space is a subset of Hilbert space. Hilbert space is a much bigger space. This is just a small part of that space. So previously we have seen that the wave function is wave functions belong to a space known as wave function space F. Now we represent the wave function in this manner. This representation is known as Kate representation, and this is an abstract representation. We don't know anything about it, its coordinate or anything. We just know that this notation represents the state of the system, and these are a vector quantity, and this belongs to the state space ER or epsilon r. So what is dual space? There is a set of linear functionals which acts on the state psi and give a number which can be a complex or a real. So linear, what are the linear functions? Linear functions are some mathematical concept. These are some kind of operator, but are not operator, because we know that an operator acts on the state of the system and give an eigenvalue and the state itself, but here it only gives a number. This is like a scalar product. We have already discussed what is a scalar product. Like a scalar product, it only gives a number. The vector space formed by these linear functionals are known as dual space and represented by epsilon r star. So this chi is what we are calling as linear functional. So real or complex number, this acts on this state psi and gives a real or complex number. This chi has a more common representation, and many of us are familiar with this notation, which is known as bra psi. So from here we can say that the Kate psi belongs to a space which is known as state space and represented by epsilon r, and the bra psi belongs to a space known as dual space, which is represented by epsilon r star. And we know that the definition of linear functional is that it acts on the state and gives a complex number. This is the notation of that operation, and later we will see that this is nothing but the scalar product of the wave function psi with itself. I have tried to draw some diagram to make you understand more what I am talking about. Let's say this is a space which is the state space, and similarly this space, there is another space which is known as dual space, and for every Kate in this state space there is a complementary bra in that dual space. if the state space, let's say 3-dimensional, we have 3 independent states, and similarly the dual space also would have 3 independent states corresponding to those 3 kate in the state space. So how can we transform any kate representation to its bra representation? Just write the bra corresponding to the kate and change the variable by their complex conjugate. That's all. And these are some representation. Let's say what is lambda psi kate. This is lambda psi kate. And what is bra lambda psi? This is lambda star bra psi. Please notice that in case of bra lambda psi, when we take lambda out of the bra notation, we have to replace it with its complex conjugate. And I have already told you that this representation is nothing but the scalar product, and we know from the property of the scalar product that the scalar product of phi psi is the complex conjugate of the scalar product psi phi. Similarly, the bracket of phi psi is the complex conjugate of bracket of psi phi. So what is the scalar product of phi with lambda psi 1 and lambda psi 2? We know that the constants come out of the scalar product, and we are left with lambda 1 phi psi 1 plus lambda 2 phi psi 2. But when the constants are on the bra side, then we have to take the complex conjugate of the constants. I just have done the complex conjugate of lambda 1 and lambda 2 here. And we know from the previous lectures that the scalar product of psi with itself is nothing but the square of the norm. And we know that a square is always a positive, and as this represents the probability density or the probability of the particle of being at a position and at a time, so this has to be real. And if psi is 0, only then this integration will be 0. And let's say A is an operator that acts on the state psi and will give a new state psi prime. We will learn about this in great detail in the subsequent lectures. So what is the definition of a matrix element? If psi and phi both belongs to the state space, the matrix element of the operator A between phi and psi is defined as bra phi A kate psi. We will be having a great discussion about the matrix element and how can we calculate them and how can we represent them in the subsequent lectures in future. So that's all for today. Thank you for watching this video. If you like it and want to see more exciting videos like this, please subscribe my channel and hit the bell icon to get notification as soon as I upload any video.